We are now looking at the exercises similar to the principal exercises. The first one is under section 7.1 and it is number 54, and it says to prove that the integral of sec to the n of x dx equals tan of x multiplied by sec to the n minus 2 of x over n minus 1 plus n minus 2 over n minus 1 multiplied by the integral of sec to the n minus 1 of x dx. Alright, so what we're going to do here is we start with our left-hand side, which is sec to the n of x dx. The next step is going to be, we are going to strip off a sec squared. So we are going to write our integral as the integral of sec to the n minus 2x multiplied by sec squared of x dx. Why are we doing this? Well, we are doing this since this will enable us to do integration by parts, because we can set our u equal to sec to the n minus 2 of x, and then v equals the integral of sec squared, and we know the integral of sec squared, right? So that's the first step of what we're going to do. So I'm going to say, let u be equal to sec to the n minus 2 of x. Then I have that du equals n minus 2 multiplied by sec to the n minus 3x. And then still the derivative of sec that I have to multiply with, which is sec x tan x, and then I still have my dx in there. So let's just rewrite it so that we have everything fitted in. So du equals n minus 2 sec to the n minus 3x multiplied by sec x tan x dx. Now I'm going to look at v. So v is everything else that's left. So v is the integral of sec squared x dx, and the integral of sec squared is just tan x. Now we are going to use our integration by parts formula, and we are going to see what this equals. So we are going to get u multiplied by v. So that means we have tan x multiplied by sec to the n minus 2x minus the integral of v, which is tan x du. And du is n minus 2 multiplied by sec to the, I'm just going to write it as n minus 2 since we have sec to the n minus 3 and sec x. So sec to the n minus 2x multiplied by tan x. So I'm just going to write this tan as squared, and then I'm going to remove that one, dx. Right, so another thing I'm just going to do is I'm just going to write this in front of my integral. So I'm going to have n minus 2, the integral of tan squared x sec to the n minus 2x dx. In my next step, I am now going to use an identity to change tan to sec. So my first term is going to stay the same. I'm not going to rewrite that just now. Then we have n minus 2 times the integral, and I can replace tan squared by sec squared minus 1, and then I still have my sec to the n minus 2 of x dx. Next, I'm just going to multiply out that bracket. So that means I'm going to have tan x sec to the n minus 2x. Then I'm going to multiply out the bracket, and at the same time I'm going to split this entire second integral here into two integrals. So I'm going to have minus n minus 2. Then I have the integral of sec squared multiplied by sec to the n minus 2. So that's just going to give me sec to the nx dx. And then I have minus n minus 2 multiplied by that minus 1. So I'm going to have a plus n minus 2 multiplied by the integral. So we're multiplying this 1 over here with this sec to the n minus 2. So it's sec to the n minus 2x dx. Let's just do that. This integral looks the same as the one that we started with. So let's write everything next to each other so that we see what we have. So we have the integral of sec n x dx equals tan x sec to the n minus 2x minus n minus 2 sec to the nx dx plus n minus 2 times the integral of sec to the n minus 2x dx. So all we're going to do now, sorry I missed the integral sign there, is we are going to take this term to the left, we're going to add it there. So we have, so on the left hand side, we are then going to have 1 times the integral of sec to the n of x dx plus n minus 2 times the integral of sec to the n of x dx. So we are going to have n minus 1 multiplied by the integral of sec n x dx. And then we have on the right hand side tan x multiplied by sec to the n minus 2x and plus n minus 2 multiplied by the integral of sec to the n minus 2x dx. And this is almost our final step. All we have to do now is we have to divide by n minus 1 on the right hand side, and then we have proven exactly what we wanted to prove. So we are going to divide that term by n minus 1 and also this term by n minus 1, and then we are done.